Hello everyone, welcome back to my channel. So in this video we will solve some more problems on Cauchy's integral formula. Okay, so you'll get around 4 to 5 videos on the problems of Cauchy's integral formula because it is very important concept for board exams as well as for competitive exams like GATE, IES, etc. Okay, so I'll give as more problems as I can. Okay, so in this problem he has given evaluate the closed integral and where C is the circle, Z is equal to 3. So first of all what you have to do is we have to find the partial fractions of the denominator Z minus 2. Okay, so it is A by Z minus 1 plus B by Z minus 2. Okay, so A value is, so just substituting Z is equal to 1 in this, so it will be 1 by 1 minus 2, so it is 1 minus 1. B is equal to, just substituting 2, so 1 by 2 minus 1 is equal to 1. So we don't know this partial fractions. Okay, so it will be 1 by Z minus 2 because B value is 1. I'm taking like this, Z minus 1. Okay, so integral of C e power 2z by Z minus 1 into Z minus 2 dz can be written as integral of C e power 2z into, so this 1 by Z minus 1 into Z minus 2 can be replaced with this, so this will be 1 by Z minus 2 minus 1 by Z minus 1 dz. So separating it, so it will be integral C e power 2z by Z minus 2 dz minus integral C, so this multiplied by this dz I am writing in this, and again second e power 2z Z minus 1 e power 2z by Z minus 1 dz. Okay, now this is of our standard form to apply Cauchy's integral formula. Okay, so here the singularity is Z is equal to 2 and here the singularity is Z is equal to 1 and the contour is mod Z minus 3. So for Z is equal to 1, so if you find mod 1 minus 3 is 1 minus 3 which is equal to minus 2 less than 0. So Z is equal to 1 is inside the contour. Similarly Z is equal to 2, if you find modulus of 2 minus 3, that is 2 minus 3, modulus of 2 is 2 only. So 2 minus 3 which is equal to minus 1, it is also less than 0, so Z is equal to 2 is also inside the contour. Okay, so that means both the singularities are inside the given contour. Now we can apply Cauchy's integral formula. Okay, now we can apply the Cauchy's integral formula. Okay, so what is Cauchy's integral formula? Integral C f of z by z minus z naught whole to the power of n plus 1 is equal to 2 pi I by n factorial into fn of z naught. Okay, so here it is z minus 2 whole to the power of 1, that is n plus 1 is equal to 1, that is n is equal to 0. When n is equal to 0, this becomes 2 pi I by n factorial, that is 0 factorial into f of 0, that is f of z naught only. So that is becoming 2 pi I into f of z naught. Okay, so this value is 2 pi I into f of z naught value is 2 minus, this is also a simple pole, so this is also n power 1. Okay, so 2 pi I into f of 1. So if you to consider 2 pi I as common, it will be f of 2 minus f of 1. So we have f of z is equal to e power 2z, f of z is equal to e power 2z. So f of 2 is e power 4, just substitute in the place of z with 2. So e power 2 into 2 becomes e power 4 and f of 1 is e square. F of 1 is e square. So just substituting those values, 2 pi I into e to the power of 4 minus e square. Okay, so this is the final answer. Okay, so this is how we can solve the questions on Cauchy's integral formula. Okay, right, we'll see in the next problem. So evaluate integral z plus 4 by z square plus 2z plus 5 dz, where c is the circle. In the first problem z is equal to 1, second problem is this, and third problem is this. Okay, so whatever may be the problem, the first thing which you have to do in order to evaluate the integral is, first of all you have to find the singularities. So finding singularities, z square plus 2z plus 5 is equal to 0. Just equate denominator to 0. So this will be of the form z plus 1 whole square plus 2 square is equal to 0. So z plus 1 whole square is z square plus 2z plus 1 plus 4 we can write. So this is z plus 1 whole square and this will be 2 square. So that is what I have written here. So z plus 1 whole square is equal to minus 2 square. So z plus 1 is equal to plus or minus I2. Okay, plus or minus I2. So z is equal to minus 1 plus or minus I2. Right, so z is equal to minus 1 minus I2 is one singularity, and z is equal to minus 1 plus I2 is other singularity. Now we have two singularities z1 and z2, so we have to check whether these are inside this circle first. Okay, so mod z minus 1, so modulus of minus 1 minus I2 minus 1. So modulus of x plus iy, we know that modulus of x plus iy is root of x square. X is minus 1 whole square plus minus 2 whole square. Okay, right, minus 1. So this will be root 5 minus 1. Root 5 is around 2 point something, 2.3 or 2.2. So 2.2 minus 1 is 1.2, which is greater than 0. That means this singularity is outside this contour. Similarly, if you find mod z minus 1 is for this singularity, if you find minus 1 plus j2 minus 1, so this is also root 5 minus 1, so it is also around 1.2, which is greater than 0. So both the singularities are outside the contour of the given circle z mod z is equal to 1. Therefore mod integral c z plus 4 divided by z square plus 2z plus 5 dz is equal to 0. As I have told you, if it is inside the contour, you can apply Cauchy's integral formula, and if both the singularities are outside, then simply that is equal to 0. Okay, so this is one of the important point which you have to know. So if all the singularities of a given function is outside the closed contour, then simply that integral value is equal to 0, and this is the example for this. Okay, now see the second question. So mod z plus 1 I. So for z1 is equal to minus 1 minus I2. So this will be minus 1 minus I2 plus 1 minus I minus 2. So I am checking for this. So in the place of z, I am substituting with minus 1 minus I2. So plus 1 is there, I have written as it is. Minus I is there, as I have written as it is. So this becomes now plus 1 and minus 1 gets cancelled. So minus I2 minus I. So this will be minus 3I minus 2. So modulus of minus 3I is 3, because modulus of x plus iy is root of x square plus y square. Since x is equal to 0, it will be only root of y square, which is equal to y. So in the place of y we have minus 3, and since modulus is there, it will be 3. Okay, 3 minus 2, which is equal to 1, which is greater than 0. So this lies outside the contour. And z2, if you find for z2, it will be minus 1 plus I2 plus 1 minus I minus 2. So this is plus 1 minus 1 gets cancelled. So I2, 2I minus I. 2I minus I is I minus 2. So same here, y value is 1. So this is 1 minus 2, which is equal to minus 1. So it is inside the circle. Okay. So when one of the singularities outside and one of the singularities inside, we have to change the given function. Let us see how to change the given function. z plus 4 divided by, so how can we write this? So this will be z plus 1 plus I2, z plus 1 minus I2 we can write. Okay, this is how we have got the singularities, right? Z plus 1 whole square plus 2 square is this one only. So again, if you find this is a and this is b and this is a and this is b, a plus b into a minus b, a square minus b square, you will get around z square plus 2z plus 5 only. Okay, we can convert this z square plus 2z plus 5 into this form, z plus 1 plus I2, z plus 1 minus I2. So it will be z plus 1 whole square plus 4, z plus 1 whole square is z square plus 2z plus 1 plus 1, okay, z plus 4 you will get. So z plus 1 whole square plus 2 square, z square plus 2z plus 1 plus 4, it is again z square plus 2z plus 5 only. Okay, so we have found that this singularity, that is if you take this singularity as z1 and this singularity as z2, so z1 is lying outside the circle, so outside the given circle, and z2 is lying inside the given circle. So we can apply Cauchy's integral formula only for z2, only for z2. So z1 should not be there in the denominator, so we have to take this z1 to numerator. That means z plus 4 by z plus 1 plus j2 divided by z plus 1 minus j2 we can write dz. Now this total will be the function f of z. Okay, this total will be the function f of z, and this is the pole here, that is the singularity here. Okay, since it is a simple singularity, so what is the formula? 2 pi I into f of minus 1 plus j2. Okay, 2 pi I by n factorial, so actually n is 0, so because we have n plus 1 here, right? In the formula we have n plus 1. Okay, let me write the formula here. So integral f of z by z minus z naught whole to the power of n plus 1 dz is 2 pi I by n factorial into fn of z naught. So we have here 1 only, so when you want 1 here, so that is f of z by z minus z naught. If you have the simple pole here dz, so we can write it as 0 plus 1, that is in the place of n you have 0, so it will be 2 pi I by 0 factorial. 0 factorial is 1 only, so this will be f of z naught. Okay, so 2 pi I into f of z naught, so that is what I have written here. 2 pi I into f of z naught is minus 1 plus j2, so minus 1 plus j2 is the pole here, which is lying inside. So which pole is lying inside, you have to take that in denominator, and the remaining pole you have to send it to denominator, so that will be a part of f of z now. That will be a part of f of z. Okay, so let me erase this. Okay, so 2 pi I into f of minus 1 plus j2, so it will be 2 pi I into, so what is f of minus 1 plus j2? So this is f of z. F of z is now z plus 4 divided by z plus 1 plus j2. Okay, so we need f of minus 1 plus j2, f of minus 1 plus j2, so it will be minus 1 plus j2 plus 4, minus 1 plus j2 plus 4 divided by minus 1 plus j2 plus 1 plus j2. Just in the place of z, substitute it with minus 1 plus j2. So this is totally z, z plus 4 divided by, this is totally z, z plus 1 plus j2. So plus 1 and minus 1 gets cancelled off, so 4 minus 1 is 3, so 3 plus j2 divided by j4 you will get. So 3 plus 1 plus j2 divided by j4 you will get. Okay, So therefore integral of f of z dz is equal to 2 pi I. So this 2 pi I am writing as it is into, okay, this is I of course, 2 pi I into 3 plus I2 divided by I4. So this I and this guy gets cancelled, so 2 1s are 2 2s are, so what you'll get, pi by 2 into 3 plus 2I. Okay, so this is the answer for this corresponding contour. Okay, so I hope you have understood that. So if for the first contour z is equal to 1, both the singularities are outside the contour, so since both are outside the contour, the value of the integral is 0. In the second contour, you have one pole lying outside because we have got the value greater than 0, and one pole is lying inside because we have got the value -1, which is less than 0. So whatever the pole, so the pole lying outside is -1 minus I2, -1 minus I2. We are shifting this -1 minus I2, the pole of Z1, to the numerator. So we are shifting it to numerator so that only the pole which is inside the contour will be in the denominator, so that we can apply now the Cauchy's integral formula. Okay, so this is the methodology which you have to follow. Next it is by applying the Cauchy's integral formula, it will be 2 pi I into f of this. So if you solve, you will get the answer like this. Okay, so third problem I am leaving you as homework. Please solve it, and if you have any doubts, please comment in the comment section. I'll solve your problems. Okay, I'll solve all your doubts, right?